Okay everybody, hello, it's me again, Mr. Hunter, and this podcast is about finding the formula of ionic compounds, such as, magnesium chloride or sodium oxide. And to do that, it's essential that you know how to get the ions from the charges, how to get the charges on the ions from the atoms in the periodic table. Because I'm just going to do a little silly thing here, maybe, am I? No. Because you really need to know that, because the ions are going to combine together. I don't like that. Okay, so the ions are going to combine together, so we need to know the charges of the ions that combine together. So we go to our periodic table, and if you remember, group 1 has 1 electron in its outer shell. So because group 1 has 1 electron in its outer shell, group 1 will lose 1 electron, so these guys will be plus 1. Group 2 will lose 2 electrons, they'll be plus 2. Group 3 will lose 3, they'll be plus 3. Group 4, well, group 4 could gain 4 or lose 4, but you won't be asked about it, but it tends to form plus 4 anyway. But we'll stay away from that, and so will your exam. Group 5, well, it's easy for them to gain 3 electrons. They're going to gain 3 negative electrons, so they'll be minus 3. Group 6, minus 2. Group 7, minus 1. Group 8 will be, well, they're already satisfied with their filled outer shell. They don't need to gain or lose anything. So they won't. They'll just stay the way they are. All right? So, here's the principle then. You're going to form a neutral ionic compound. So for magnesium, which is in group 2, when it combines with chlorine, which is in group 7, just quickly look, magnesium group 2, chlorine group 7. So when that happens, they will form a neutral compound. Now when they form a neutral compound, you just need to work out how many ions are required to combine with each other. Magnesium is 2 plus because it's in group 2. Chlorine is minus 1 because it's in group 7. There's 2 ways you can think about this. Think of how many plus 2s and how many minus 1s need to combine together to become neutral. Or how many negatives need to neutralize the positives, as it were. Now you should see with a little bit of thinking that you need 2 negatives, 2 minus 1s to cancel out your plus 2. You may have done something like form a block in class. Here's a plus 2 block, and if that's a plus 2 block, then this is the size of the minus 1 block. Notice that you need 2 minus 1s. Another way to think about it is you just cross over the numbers on the charge. The 2 goes here, and the 1 goes here. And you end up with MgCl2. No matter which way you decide, it's going to be the same way. Whether you do the form a block, or think of the pluses and the minuses, or cross them over, you'll get this formula. Have a think about this. It means that you've now got 2 chlorines for every 1 magnesium. 2 times minus 1 is minus 2. Cancels out with a plus 2 to give you 0. Okay? Let's try one more example. Sodium oxide. Well, for sodium, it's in group 1. It will have a charge of plus 1. Oxygen, oxide, minus 2. Okay. So sodium, plus 1. Oxygen, minus 2. You'll need 2 plus 1s to cancel out the minus 2. Na2O. Well, hopefully that makes good sense to you. Here's some examples for you to try on your own. Iron 3 fluoride. Oh, I need to tell you something about iron 3 fluoride. So let's have a little look at this. I don't like that. I'm going to remove that. Let's have a little look at iron 3 chloride. Okay, back to the periodic table. Now, you may remember that between groups 2 and group 3 we have these transition metals. Assume these to be +2 unless you are told otherwise. For example, iron 3 something is telling you that it's not +2, it's +3. For example, iron 3 chloride. There are many other examples, but for the moment it's good for you just to assume +2 unless you're told otherwise. Another common different one is silver, which is +1, and chrome, which is +3. But remember, just assume +2 unless told otherwise. So that means iron, in this case, will be +3. And fluorine, it's -1, because it's in group 7. So work out these formulas now. So it's FeF3. For aluminium sulfide, aluminium's in group 3, sulfur's in group 6. Al2S3. For calcium nitride, calcium's in group 2, nitrogen's in group 5. Cross them over, Ca3N2. Super! Hope you're doing alright there and you understand that, and that's why you get a smiley face. Now we're moving on to a little bit more tricky, and that's using these guys here. These are the polyatomic ions. Now polyatomic ions, many atoms making one ion. So the charge on carbonate consists of 1 carbon and 3 oxygens all bonded together, giving you a charge of -2. Sulfate, 1 sulfur, 4 oxygens, giving you -2. Nitrate, 1 nitrogen, 3 oxygen, giving you -1. Hydroxide, -1. Phosphate, -3. Hydrogen carbonate, -1. Ammonium, +1. So when you use these guys, for example, ammonium chloride. So you need to learn that table. Ammonium is +1, chlorine is in group 7, which is -1. Now note that you can get the chlorine from the periodic table, but you can't get these guys from the periodic table. You must learn these guys. You've got to learn this table. There's no other way around this. You will not get this in your exam. Cross over your plus and minuses, they'll cancel out, NH4Cl. Let's choose a harder example, because that one was a bit easy. Aluminium hydroxide. Aluminium's in group 3. Hydroxide, well that's up here, so it's -1. Well, you're going to need 3 hydroxides for every 1 aluminium. But you must show that you've got 3 hydroxides by using brackets around the whole thing. Not like this. This just shows 3 hydrogens and 1 oxygen. You've got more than that. You've got 3 oxygens and 3 hydrogens. The hydroxide, the polyatomic ion, never is separated. This is always together. Here's some more examples. Let's do iron 3 sulfate. You can do these now. Iron 3 sulfate, copper 2 nitrate, and here's another one, zinc hydroxide, and calcium phosphate. Okay, try them now. Okay, so it's iron 3, so that means it's iron plus 3. Sulfate is SO4 2-. How do you know that? You look up at this table which you have learned and you find sulfate. Mr. Sulfate is there. You'll need to combine them in this ratio, Fe2, SO4, 3. Notice that means you need 2 ions for every 3 sulfates. 2 times plus 3 is plus 6, 3 times minus 2 is minus 6. They cancel out. And notice the use of the brackets. It's not O43 or O12, it's SO4 times 3. Copper 2 nitrate, well, the 2 tells you copper 2. If it didn't tell you that, you would assume it to be 2. Cross over, CuNO3, close bracket 2. Calcium phosphate. Calcium is in group 2. How do you know that? You look at your periodic table, don't you, you silly boy and girl? Phosphate, PO4 3-. How do you know that? You look up at your table, you have learned this. Not the periodic table, but this table which you learned. You find Mr. Phosphate. Therefore, it's Ca3PO4, all brackets 3. Finally, zinc hydroxide. Zinc is a transition metal. It doesn't say 2, 3 or anything. You assume therefore it to be 2. Hydroxide is -1. It's in your table of ions that you must remember. ZnOH2. You are done. Big smiley face because you really know that you can do this a lot. Is that a smile? I don't know. There you go. So, it's goodbye from me. Cheerio!